Hello, my name is Seco from the Research Center in Territory Architecture and Design, CITAD, Lusíada University in Lisbon, Portugal. I am presenting a study developed with my colleague Elsa Negas, also from CITAD Lisbon. It is an instrument for urban infrastructure assessment, a method of calculating the level of urban infrastructure and basic urban services on a given territory. This instrument has been created to analyze a specific territory, the area of the Tagus estuary nearby Lisbon. However, it is actually applicable to any point in the territory. Over the last 3 centuries, the city was deeply transformed while it spread widely. 3 different urban revolutions have occurred since the industrialization, as refers François Acher. And this process of transformation is still in progress over large areas of the globe. As a word and as a concept, the city has been substituted by urbanization, urbanized territory, suburbanization, urban sprawl, ex-urbanism, and other terms according to different languages and perspectives. Alain Bourdin states that this imprecision and comprehensiveness of concepts hinders reasoning and hampers planning and urban management. This study aims at contributing to a more accurate knowledge on the territory and the city, basing on the analysis of data about infrastructure and basic urban services. It proposes an urban infrastructure level indicator to assess the differences in urbanization levels. This follows other fields of knowledge, from climatology to health or social responsibility, which have already created indicators that measure complex situations comprising multiple factors with variable relative weights. The availability of infrastructure is not uniform throughout the territory, yet it is of great significance at the present time, given our way of life more and more based on technology, accessibility, and communication. Basing on the review of recent theory about the city and urban development, factors such as mobility, transports, connections, roads, access to media and information, data networks and digital communication, as well as traditional city infrastructures, water supply, electricity, sanitation, and urban services, administration, commerce, public services, are all considered in this analysis as factors that establish urbanity, fostering economy and social development. This set of parameters is evaluated taking into account their relative weight to obtain an overall assessment of the infrastructure level on a specific location. Urban infrastructure is here considered in a broad sense, integrating usual urban attributes like roads, pavements, electricity, network, water supply, sanitation, etc., but also a set of urban services and facilities traditionally provided by city and urban environment, administration, representation, culture, health, education, and security, among others. And also other conditions diagnosed as significant for the current evolutionary trend of extended urbanity, such as mobility, integrating roadways, public transport networks, soft mobility devices and infrastructures, and access to and integration in communication and information networks, voice and data communication, fixed and mobile. The development of this calculation method takes into account the relative weights of this set of conditions in order to obtain a balanced assessment of the level of infrastructure. Our goal is to create a process for the easy pondered rating of the infrastructure level on a specific location. A process of testing in the field will enable the fine-tuning of this balance through its use in different conditions and areas of the territory. Once defined the process, the classification can be applied to any place in the world, enabling to compare different points in the territory. This will help to understand and assist urban planning and management, diagnosing inequalities, calculating progress over time, and estimating the impact of measures throughout planning processes. It must be noted that the relative weight of the factors in the formula may vary in the future according to the purpose of its use. That is, distinct variants of calculus may be developed in order to evaluate different aspects of the urban condition. To settle a business, the most important issues to assess are not the same of those to verify the urbanity of a residential neighborhood or the urban integration of a university campus. On the other hand, the use of specific versions of this tool to systematically assess a given area of the territory will enable to compare, to identify disparities and relative advantages, and to evaluate progress over time, creating new and reliable data that can be used to support urban management, decision-making processes, and spatial planning. We now present the design of the index integrating all items identified as having influence in the infrastructure of the territory, grouped into categories with different relative weights. First, the transport systems. It's the first category. We consider the public transport 1 and 2, the availability of 1 or 2 transports, an airport, the existence of a good set of public transports, and the existence of night transports. These factors have specific ponderings in the formula. For transport classification, the following factors are considered prevalent: proximity of access, frequency of passage, and the existence of a network of at least 2 distinct means of transport. As the notion of proximity and accessibility is subjective, it was made uniform as follows. In the infrastructure index, the distance is calculated based on the duration of a walk, considering that 5 kilometers are traveled in 1 hour. All accesses at a distance of 200 meters or less are considered to be very good, corresponding to a 2.4-minute walk. In the second category, basic urban services, we consider as basic urban services existence of tax office, of a post office, banking services, cinema, theater, a congress center, an exhibition center, and tertiary sector levels 1, 2, 3, and 4, schools levels 1, 2, 3, and 4, higher education, and these factors all have specific ponderings. Infrastructure influences and is influenced by the existence of services, culture, and leisure, as well as the existence of educational institutions at different levels and tertiary services. In this case, different levels are also identified. In this criterion, the distance from where services are located is relevant and should be discriminatory. In this sense, all services that are more than 2.5 kilometers away, corresponding to a 30-minute walk as previously considered, should be classified as absent. Hence, proximity and accessibility are valorized in this criterion. The third category is urban infrastructure, basic urban infrastructure, and we consider it having water supply, sanitation, street lighting, electricity, free collection of large waste items, the existence of recycle bins, solid waste collection, handicap accessibility, soft mobility lanes, urban equipment such as benches, and these factors all equally have specific ponderings in the formula. Regarding the category that classifies the urban infrastructures existing in a given location, the following analyses were considered: existence or inexistence of infrastructure, if existent, its updating and modernity, its quality, durability, and suitability for the environment. The fourth category is automotive accessibility. We consider in automotive accessibility the quality of the roads, the proximity of the spot to motorways or expressways, the existence of parking, and all these factors have specific ponderings in the formula. The level of infrastructure is also determined by the quality of the roads, the proximity to highways, that is, ease of circulation, accessibility, the possibility of parking, and even safety. Facility of circulation has to be rated taking into consideration the quality of road connections and safety. The fifth category is telecommunications. We consider in telecommunications the number of providers, the type of communication, the quality of the connection, and these factors all have specific ponderings in the specific formula of telecommunications category. In this category were valued the following factors: the type of internet connection, the availability of fixed and mobile data connection, and the number of available connection providers. In the Portuguese situation, for example, the availability of connection on a specific location can be consulted online. It is a fact that some areas only have the possibility of ADSL communications, while others already have the possibility of fiber optic connection. The infrastructure index must highlight this difference in a reinforced way. It should be noted that a binary variable has been created. Thus, the entire category takes on the value 0 if there is no possibility of installing a landline telephone. The overall assessment, following the calculation of the index for each category, is calculated the overall infrastructure index, assigning the relative weight to each category. The infrastructure overall assessment is the outcome of the calculation through the formula. This comprehensive equation encompasses the weighting of the 5 key categories, in turn resulting from the weighted calculation of the subcategories that compose them. The sum of all weightings equals the unit. This aggregate index intends to allow the assessment of the existent infrastructure, aiming at the interpretation of the territory and its potentialities. The consideration of such a large number of items requires the quantifiable treatment of each of them and their total and relative weighting. It is important to recognize the balance between each item in the category to which it belongs and the weighting of the category in the global assessment. The aim is to calculate the infrastructure level in different places, allowing the identification and quantification of asymmetries. Testing the implementation of the aggregate index in the field, in different geographies, realities of the territory, will help to fine-tune the balance and relative weighting of the categories and sub-items. This will constitute the next stage of the research. It will then enable the use of the infrastructure urban assessment tool as an evaluation method to produce analytic data that can then be cross-referenced with other indicators like the development level, education level, unemployment rate, or birth rate. The Urban Infrastructure Assessment Tool intends to become an operative contribution to the analysis of the territory, considering, however, that, as André Corboz stated, complementary knowledge in addition to statistics and quantification, enabling it as a subject semantified and discursible, is also indispensable for its understanding. Thank you.